For centuries, physicists believed nature operated like a giant machine, governed by precise laws. If enough information were known, scientists thought the future could be predicted exactly. Classical physics assumed the universe was orderly and completely understandable. But during the 1920s, a young German physicist named Werner Heisenberg introduced an idea that shocked the scientific world. His uncertainty principle suggested that there may be fundamental limits to what the humans can know about nature itself. Quantum mechanics would forever change humanity's understanding of reality. Niels Bohr atomic model had made a major breakthrough. It explained hydrogen spectral lines and introduced quantized energy levels. However, physicists soon realized the model was incomplete. It worked well for hydrogen, but more complicated atoms produced contradictions. Electrons did not behave like tiny planets orbiting the nucleus. By the 1920s, scientists understood the deeper theory of matter was needed. Werner Heisenberg was born in Germany in 1901 and grew up during a period of enormous political and scientific change. As a young scientist, he showed exceptional talent in mathematics and theoretical physics. He later worked with Niels Bohr in Copenhagen, where many of Europe's brightest young physicists gathered to solve the mysteries of the atom. Together, they helped create an entirely new form of physics. The microscopic world refused to obey the rules of classical physics. Electrons sometimes behave like particles and sometimes like waves. Attempts to describe atoms using ordinary mechanics repeatedly failed. Physicists realized that centuries of assumptions about nature might be collapsing. A completely new understanding of matter and energy was beginning to emerge. In 1925, suffering from severe allergies and exhaustion, Heisenberg traveled to the isolated North Sea island of Helgoland, away from universities and scientific debate. He worked intensely on the atomic problem in near isolation. During long nights of calculation, he abandoned classical pictures of electron orbits and developed a radical and mathematical approach later called quantum mechanics. This work became one of the foundations of modern quantum mechanics. Matrix mathematics played an important role in the breakthrough. If you'd like a refresher on matrices and determinants, I have an algebra playlist on this channel covering these topics. In 1927, Heisenberg introduced the uncertainty principle. The more precisely the position of a particle is known, the less precisely its momentum can be known, and vice versa. This was not a simple limitation of technology or human skill. According to quantum mechanics, uncertainty appeared to be built into nature itself. The implications were shocking. Classical physics assumed the universe could, in principle, be measured and predicted exactly. Heisenberg's work suggested that complete certainty might be impossible at the deepest levels of reality. Albert Einstein admired quantum theory, but rejected the idea that nature was fundamentally uncertain. He believed quantum mechanics must be incomplete. Niels Bohr defended the new idea, while Einstein challenged it through a series of famous debates that lasted for decades. Their discussions became some of the most important scientific and philosophical arguments in modern history. By the late 1920s, the old picture of reality had begun to collapse. Quantum mechanics described a world governed not by certainty, but by probabilities and wave behavior. Particles no longer possess simple, well-defined paths. Instead, physics became a theory of possibilities and probabilities. The mathematics worked extraordinarily well, yet the implications implied deeply strange and unsettling behavior. The macroscopic world no longer behaved according to everyday human intuition. World War II complicated Heisenberg's legacy. Unlike many scientists who fled Nazi Germany, Heisenberg remained in his homeland and became involved in Germany's wartime nuclear research. Historians continue debating his wartime role and intentions. After the war, Heisenberg returned to scientific work and helped build Germany's science. His wartime activities remain controversial to this day. Werner Heisenberg helped reshape humanity's understanding of reality itself. His uncertainty principle revealed that nature may not operate with perfect certainty at microscopic scales. Today, quantum mechanics forms the foundation of modern physics and technologies ranging from electronics to computing and medical imaging. More than a century later, Heisenberg's ideas continue to challenge scientists, philosophers, and anyone seeking to understand the nature of reality. Thank you for watching.